question is from GATE 2011 Mechanical Engineering paper, question number 5. A double parallelogram mechanism is shown in the figure. Note that PQ is a single link. The mobility of the mechanism is. Let's see how this question will be solved. Now, mobility of the mechanism that is to be found here refers to number of independent variables of the mechanism or of the system. Number of independent variables of the system is also called as degrees of freedom. So in short, we need to find degrees of freedom of this mechanism in this question. Formula for finding degrees of freedom is 3 into L minus 1 minus 2J minus H, where L are the number of links, J are the number of lower pair of joints, that is the one having each 1 degree of freedom, and H are the higher pairs, the number of joints which are higher pairs, that is having 2 degrees of freedom per joint. Let's start by counting the number of links. Number of links are this fixed link 1, this link 2, 3, 4, and PQ being a single link, this is the fifth link. Let's count the number of joints now. So we have 1, 2, 3, 4 and 5. So these are the binary joints or the lower pairs. We can write here number of links L we counted as 5, number of joints J, number of lower pairs we counted as 5. Now let's see what are the number of higher pairs here, small h. So this can be considered as a higher pair H because this joint rotates, there will be a slight slide here. So there are 2 degrees of freedom at this joint. We can say small h is 1. Let's substitute and find out the degree of freedom. Number of degrees of freedom, this is number of degrees of freedom. We have 3 into number of links 5 minus 1 minus 2 into number of binary joints 5 minus number of higher pairs is 1. So this becomes 5 minus 1, 4 into 3, 12 minus 5 into 2, 10 minus 1, 12 minus 10, 2 minus 1, 1. So what are the number of degrees of freedom? We have 1 degree of freedom here in the system. Let's go back and mark the correct option. Answer is option C. Mobility of this mechanism is 1. To learn about degrees of freedom in detail, you can refer to the NPTEL video Lecture 4 Degree of Freedom from the course Kinematics of Mechanisms and Machines by Professor Anirvan Dasgupta. He is from Department of Mechanical Engineering, IIT Kharagpur. I hope this solution will help you clear your doubt. Thank you.